Hello, I'm in Llangollen today and I spent 6 weeks here mapping during my university degree of geology at Liverpool Uni. Now every geology undergrad at university has to do a fieldwork mapping project at the end of their second year, and I chose mine. I chose to do mine in this spot here. Now I knew Llangollen was limestone, one of my favourite rocks, and so to spend 6 weeks mapping it sounded good. Now I didn't know how interesting it would be here in Llangollen before I started mapping it. It's a brilliant story to be told here. You've got ancient Silurian deformed basement bedrock, and then you've got the Devonian missing. Where's it gone? And the Carboniferous, we have this whole succession from sort of lagoonal limestones into shallower limestones, fossil coral reefs, all the way up into beach sediments. And then we have this story of a changing environment from marine to freshwater. So what we've got here, we've got the Silurian basement rocks down in the town and along the River Dee, down at the bottom of the valley here that we're in. Now these rocks are being folded and deformed and faulted. It's an absolute nightmare trying to map it. I did not enjoy that. I'm not going to bore you with the story of that stuff. It's just deep water ocean things, and they've had a rough time. They are folded, and you can see it on the geological map of the area, over a large sort of radius. And so the valley that we're sat in, and the town of Llangollen, and this entire escarpment, all these limestone rocks are deposited within what is called the Llangollen synclinorium. I love that. It's basically a massive syncline, which is a massive U-shaped fold in the valley. And so all these limestone rocks, which were forming in a shallow sea, were sat inside that sort of bowl-shaped basement rock. And then, where's the Devonian? The Devonian in this part of the world, after the closure of the Iapetus Ocean, the Devonian represents the time period where North Wales was on land. It was a landmass, and therefore there was not much deposition of sediments happening in and around this area, and just a lot of erosion of this mountain range, this newly formed mountain range, after the collision of continents during the Caledonian orogeny, when that ocean closed. And so the Devonian's missing. All we've got to show for it is a really small sort of red layer of clay soil. That's at the very base of the escarpment here. And that represents sort of this. There's a classic rock called the Old Red Sandstone, which represents the Devonian. And that's probably the remnants of that in this area. But on top of that is where the base of the Carboniferous limestone start. So that gap in time is what we call an unconformity, because it represents an entire geological period of the Devonian just going missing. And now we're going to look at the Carboniferous. So the first few layers of limestone, that brownie coloured muddy one, that's got bits of plant material in it. And so we think that one is potentially some sort of like lagoonal limestone, where periodically bits of plant material from the land are being washed in and captured in that rock. Then above that we have this massive bedded limestone, which just represents a shallow marine environment. Not too much to say about that. And then as we move up the sequence, we move into fossiliferous beds and thinly bedded limestones with loads of paleokarstic surfaces, indicating a more disturbed and shallower environment. But I'm currently walking up now. I'm walking up what's called the Panorama Road. Absolutely stunning views. I'm heading up here to go and see the really interesting bit, which is that transition from marine to terrestrial that I'm not sure can be seen anywhere else. And would you look at that? Keele University here. I bet they're geologists. Okay, so there's the River Dee. There's the River Dee flowing along the bottom of the valley. that valley that goes around that small hill here, that's an old meander of the day. It used to float around there and back. So that's all the basement rock down there. Dinas Bran, that castle, bit of an outlier. That is still the basement rock, but it's a particularly hard bit of basement rock. So this landscape we all see here is all erosional, glacial valley landscape. All the rock is the same type, Silurian basement rock. So here we are at the limestone. This is the interesting stuff. It's got some fossils in it. It's nice. There's some massive beds here. This is a weird layer of mudstone in amongst the limestone. So that represents a change in water depth, either a major shallowing event or a major sort of sea level rising, so it becomes more deeper water event. This is an individual bed of limestone, which represents a period of time where that stuff was being deposited. Luna, can you stop crying? And then this layer on top, you see the bedding surface is all wavy and ripply. That's because that is an erosional surface. So that means at that point in time, sea level dropped, exposed this surface to the sort of air, the atmosphere, if you will, and then it was eroded over time and became sort of bumpy and wavy, and you imagine like a limestone pavementy surface would. The rain and other things has eroded it down. You do have a thin layer of sort of mud that's formed inside it. That's probably what you would call a paleosol. So that's a sort of soil that began to form, and then sea level rose again, and he carried on depositing layers of limestone on top. And each one of these beds, because of the waviness of it, is one of these sort of exposure surfaces. And we call those paleokarsts. So that means it's a karstic surface. So limestone forms a karstic surface when it gets eroded. And it's a paleokarst because it's a bloody old one. So there you go. So it's a constant cycle of sea level change. The sea level just couldn't settle down at this point in time, and we have all these paleosols kicking right off. And there are some nice fossils in here. We zoom in on this. This is a colony of coral. So to sum this spot up, what we've got is a hell of a lot of sea level change recorded in a generally shallow marine environment, and this is about 350 million years old. Okay, this is where it starts getting interesting. So we're further up the road now, where we're further up the sequence because the rocks are dipping in this direction. So this stuff is younger than the limestones we were looking at before. Now it looks like limestone at first appearances, but you can see all these layers in it. And each layer that's sticking out a bit, it's got a bit of relief, is like a sandy layer, and the layers in between look more like limestone that we were seeing before. These layers that are sticking out are lovely rounded quartz grains, like beach sand, and they're cemented by calcite cement, so that's from the limestone stuff. And the layers in between are more limestoney, but there's still bits of quartz grains in there. So what we've got here is basically a beach environment, and each one of these layers represents some sort of cyclicity that was happening, maybe seasonal weather patterns that create different tidal effects throughout every year or something like that. That's creating layers of more coarser sand layers, and then these layers of finer grained, goes back to more muddy limestone stuff. So that's happening over and over and over again in this sequence. So now we're on a beach environment, we know that. But what's different about here is these rock units, this one that I'm touching right now, is dipping at a different angle to the stuff we were looking at before. Everything else is dipping like this direction, and this is dipping like that. So why is that? Well, at this time in the Carboniferous, the Variscan orogeny was happening. But what's going on here, at this time, the tectonic plates were starting to shift, and you had these sort of tectonic blocks, these sort of bits of the crust of the earth that during this deformation that was starting to happen, these blocks were shifting and tilting. So you got a limestone like that. There's deformation, tectonic deformation. The beach sands are deposited. There's deformation again to tilt it back to the original angle. And then there's a period of erosion between. And so what we've got here is an unconformity layer, an angular unconformity, because all these beds are being cut off at that angle. Because that's because that was the new surface. There was erosion on that surface, and then deposition of these beds above, which are different again. So let's take a closer look at these. So at the very bottom, after that tilting event, we've got more of those beach sediments being deposited, but they're all deformed and wavy and funky. So they're not happy, and deformation was still going on when these things were soft. So that's interesting. And then a change environment happened. We had a river influx, and the ocean water shallowed again. So we moved away from a beach and into rivers. So you can see this is full of quartz grains, and they're angular and poorly sorted, and they're laid in this direction. So this is the start of a millstone grit. It's a coarse sandstone, and it's deposited from high energy rivers, which are happening completely different to the beach environment that caused this. It might be a bit tough to grasp the idea that these sort of tectonic blocks are shifting and stuff as things are going on. But we do have even smaller sort of precursor events to that stuff happening. If we look closely within these beach sands, there are these cracks running through. And there's cracks at different angles. There's a slanted one there, and there's these vertical ones here. And if we look really close at the vertical ones, we can see that they are ever so slightly faulted. Okay, so this is the upthrow side, that's the downthrow side, and they've shifted like that. So that's a fault activity on that plane there. We've also got this diagonal plane in which these sandy beds are sort of smeared across this fault surface. And that is because this happened when these sediments were still wet, so they weren't turned to rock yet. And that is what we call sedimentary deformation. So during the formation of these beach sands, we had this sort of minor fault activity starting to happen and starting to deform these sediments while they were still soft. And that is a precursor for the big shift that happened that tilted this entire block and created this as the new surface before erosion happened, and then the rivers started forming the sandstone, the millstone grit on top. This is the only outcrop I've ever seen showing this transition, the classic transition that can be traced across the whole country, from shallow marine limestone environment to beach sands to millstone grit, and then eventually to coal measures. It happens everywhere in the Carboniferous. It's a global theme. I can't see evidence for it anywhere else but this locality here. So the entire sequence of events, let's run through it. Silurian ocean closes up, rocks get deformed, they're horrible, slaty, siltstony messes from that ocean floor that are turned to rock over millions of years. The Devonian period is missing because we're not in the water, so there's nothing getting deposited. That Silurian basement is folded, and you get a bowl shape like this. And inside that bowl shape is where these marine sediments start to form. So we have the base of the escarpment, get a limestone with plant bits in it. Then you move into a blocky limestone with nothing in it, a fossiliferous limestone with loads of exposure surfaces because sea level is changing like mad. Then there's a shift, tectonic activity, a shift, as must be an unconformity underneath us, and you get a completely different bedding angle of these beach sands, and then a shift back to the original bedding angle, and you get deposition of the sandstone above, which is turning into a river environment, a fluvial environment. Okay, I'm making my way up to the top of the escarpment now. So I'm down dip, I'm up the sequence from the limestones, I'm heading up here. It is boiling hot, so I don't think I'm going to try and go right to the top, just to save these doggies, but I will show you the change in rock type. I'm sure you can notice there's been a stark change in the vegetation type. So it's all heather and that sort of heathland plants dominate up this area, and that is because geodiversity underpins biodiversity. And so a complete change in rock type forms a different type of soil, which then a different type of plant grows on. So it's actually a really useful tool in mapping, is to look at the plants that are on the surface, and that can tell you a bit about the rock type under your feet. So this new rock type, what is it? Let's have a closer look. Thankfully, some troll or giant has thrown this massive boulder off the top for us, so I don't have to walk all the way up to see it. So it forms big clunky boulders right at the top. It's well jointed. It's fairly coarse grained, and this is the rock type, a very well known rock type called Millstone grit. This is a typical relief of a sort of millstone grit escarpment with its blocky nature. I believe it's very good for boulderers to climb on. And of course, it's called Millstone grit because it was used for millstones. Because it's a nearly purely quartz sandstone, it's really gritty. Quartz is, of course, a hard mineral, and so perfect for grinding stuff up. I'm afraid you're going to have to take my word for it a little bit here, because I just can't walk up to the top today. It's too hot. There are some small examples here of small pebbles. There's a few in there, and so the fact that this rock's got pebbles in it, those pebble grains are bigger, much bigger than the standard sort of quartz grains that are in this rock. So a higher energy flow of water was bringing in those pebbles and mixing it up with all the sand grains. So we're talking about big rivers here, washing in sediment from upland, all freshwater stuff. So there you have it. The Geology of Llangollen explained, I hope. Some fantastic outcrops, and tells an incredible story covering a vast amount of deep time, and a very important story for the formation of most of the rock formations we have in northeast Wales. You couldn't ask for better rocks with a better view. Dr. Tom signing out.